For you here today. This one is from our friends at Olympus. Rob Bellinger of Olympus comes down to our studio often to look at their great stuff. And this one is the STM7 series from Olympus. So Dirk and Rob, take it away.
Yeah. Well, thanks, Rob. Thanks again for joining us. So STM7, what are we looking at?
This is our new model measuring microscope, or sometimes known as a toolmaker's microscope. It's comprised of a measuring stage and components. I'd probably like to show some of the hardware configurations of this.
Yeah, I think we've got a video we can run that kind of points out some of the features. Sure.
Yeah, we have a video that goes over that. So this system has a motorized focus that we have displayed here, a very high resolution digital camera for live image display, a display on the side that actually shows your XYZ coordinates, and you can reset these to do quick point-to-point measurements. We also have reflected light with a laser autofocus system for Z measurements accuracy. The bright field illumination with our compound objectives. We can also utilize our measuring objectives that give you more working distance, or toolmaker objectives. The most important part is our XY stage here that has encoded, and it's all based on a granite platform for vibration isolation.
Cool, interesting. So that's the, you say this is basically what we're used to calling a toolmaker microscope, right?
Toolmaker microscope, it's for critical part measurements and quality assurance on your parts for dimensional, or it could be for repair type imaging.
And as usual, this has got a very simple Olympus interface, right?
Yeah, so a lot of this new features are ran through the software that Olympus has designed for the measuring microscope. Utilizing our high refresh rate camera, we can now do part measurements on the screen and utilize a lot of features in the software for repetitive measurements and auto edge detection. So that's something I want to go through here. We've actually created a measurement list, so we can replay this list. And when this comes up, it actually will prompt the user, how many times do we need to take this measurement? So you might have 10 of these parts on the stage. You would replay this 10 times and take the same measurements on all 10 parts, because they all have the same exact holes drilled in them and such.
So you've pre-programmed a measurement routine.
A routine, yep.
Okay.
I like to call it a macro sometimes, but yeah, this routine will guide the operator to take certain measurements, and with the auto edge detection capability, it'll automatically mark the points for them as they move through it. So let's do this one real quick. It's a short one. We'll just do a single replay. And what it's going to come up with first, asking us to mark the points along the edge to define the rotation alignment of our part. So it's on the screen here, you can see the line profile, and as we move across, it will auto mark the edge with a red crosshair here, and we can just mark our get points.
So it's automatically found the edge for you.
Automatically found this edge based on a contrasting technique. So we mark the left side, and we're going to go all the way to the right side of our part here, so we can quickly mark the right side, giving us the most accurate rotation alignment.
And I noticed the part isn't perfectly aligned on the stage.
Purposely did that for this demo, yeah. Okay. So it's not perfectly aligned, and it's marking this automatically on the edge here now. And this edge scanner bar goes across almost our entire field of view, so we don't have to work with bringing the part right to the exact position. It marked it automatically. Now the next thing we have to do is mark the left side edge of the part, and this will give the software the definition of where the part is located on the stage. So we'll mark our left side edge, and then we'll go to the top of this and mark the final point up here, giving us not only the final position, but the rotation as well. So it marks this edge right here.
Yeah, what people aren't seeing, there's a little tiny, you can probably see the big red crosshair, but there's actually a little blue crosshair that's actually finding the edge, right?
Finding the edge right here.
Yeah.
So we hit get coordinates, and once it's done with that, you can see in our graphic here, on the right side, it marked our two lines, and it then automatically marks the angle of rotation and our origin point, which is the bottom left corner of our part.
And that's why you took 2 points on the bottom. You could get that.
2 points for rotation alignment.
Gotcha. Right.
Yep. So now that we have our origin and it knows where the part's located, this system will actually guide the user to drive to the location where the measurement point's going to be taken. And right now we're measuring a circle. So all the user has to do is drive following this red dot. Once they get to the point, then they need to drive it down. and moving the stage here. Once it gets close enough, it automatically brings up that auto edge detection again.
So you didn't do anything right there. It saw this is a circle, this is what I'm supposed to measure, and boom, it finds it.
Because we programmed it to do this. We know that it's going to be measuring a circle, so it's looking for a circle. As soon as it comes into the field of view and marks to the point it needs to, it's going to bring up this definition. This one's marking 10 points. We can mark up to 100 points. And we just hit get coordinates here, and it automatically measures our circle. Now the next point I want to measure is a point between a height point, 2 points in Z height.
Z, okay.
So this system does XYZ measurements, and we use an autofocus, so it'll automatically focus on the surface of our part. And we'll drive down to the edge here so we can measure off the edge of our part to get part thickness. So as soon as I reach our edge point here, it'll automatically mark. We'll make sure we're focused with the laser on the surface. We'll get our Z coordinate, and then we'll move down again and refocus to the bottom surface. You notice our part went out of focus now.
Oh, so now you're focused on the stage.
Focused on the stage.
Okay.
So we'll get total part thickness. So we hit get coordinates here. And
So it's measuring from the stage to the top of the part.
to the top of the part, getting us Z height or thickness.
Okay.
So once we're finished, it'll let you know replay is finished. And all of our measurements show up in the bottom right corner here. The measurements, if we scroll up, you can see the circle measurement and our height measurement. One of these is in red, the diameter for the circle. That's telling us right away that that circle measurement was out of tolerance and it failed.
So along with programming what you're going to measure in the part, you also putting in or could put in the tolerances
Put in the
as well.
tolerances for every measurement that you want to do on the part, so it gives you quick notification of pass-fails. And once you have all this measurement data, you probably want to output it to Excel with a single button click here. Notice even in Excel, the tolerance that it was out of tolerance shows in red.
Okay, so you've just opened, okay, you just actually opened up an Excel table.
Dropped it right into an Excel table.
Okay.
And one of the other things the software has built in is report templates that can be customized. They can drop the measurements in the report templates along with captured images that you want to take pictures of. One of the other features that I want to show real quick is the ability to capture a good image of different focal planes. So let me move to a different part I have on the stage here and refocus on that. So if we look at this, we have the letter A that's embossed above the surface of this. So if we focus down, we can see the surface. If we focus to the top, we see the letter, but the top is focused, bottom's not. We have a function, an optional software component called Extended Focal Imaging, or EFI. If we go into this, it allows us to bring focus to our top surface, and we just mark that we have the upper limit position. And now we go to the lower point of focus down to the base, and we say our lower limit position. And since this is a motorized focusing system, we just hit start, and it's going to go through and capture all of those images automatically for us, creating a one in-focused image.
So you manually focus on your top, manually focus on the bottom. It records those.
You mark those points, yeah.
Okay, and then it just scans it through all the way through them. Okay.
And it scans all the way through, and once it's done, it'll compress the image into one.
Okay.
That's all in focus. Okay. So it looks real nice. These images are great to use in your reports, which you can now save out and insert into your report document, or you can just save it out as a standard image.
So a way you might use this is giving you the height from, is giving you the height of that letter, for instance.
It's giving you it in focus as a picture.
Yeah, but you also can take measurements of that as well. So you can also say how high it is as well.
Absolutely.
Right?
We could go back and mark the point on the surface, zero it out, or mark it in our software and measure down to the base and get exact heights of that point.
And along with that, you have an image that is completely in focus. I can go along with that measurement,
in the report.
for instance. Okay, a report.
Yeah.
Okay.
One of the other features that the optional capabilities of software is some stitching capability. So if you have a part that you want to take and stitch together a large area and have one picture of it, you can do this in the software as well by just driving the stage around, and it automatically captures all the pictures together for you.
Okay.
To create a large view.
All right.
So.
And what's basically the market for this?
So this has a broad market range. It can go from medical device, looking at small medical device parts, or even semiconductor parts, looking at critical line widths, to large part manufacturing. So this is a 50 millimeter by 50 millimeter stage, but we also have up to a large 300 millimeter by 300 millimeter stage, so you can fit larger size parts. So everybody from valve manufacturing, looking at races and bearings, can put parts on here and do critical part measurements and Z height measurement as well.
Okay. This is motorized. Is there a manual version of this as well?
Yeah, so all of the stage options, we have either a motorized focus or a manual focus option available. And the software is also optional, but you lose, some of the capabilities if you don't have that. If you just want to use the readout on the side and do just quick point to points, that's possible as well.
Okay, so the highlights are programmable. The measurement routine is programmable, so a user just has stepped through the operation. Right?
Absolutely. So using the programmable measurement features, operators will step through. Some variability of their measurements are going to be reduced from the auto edge detection, and utilizing the autofocus unit will improve repeatability for height measurements as well, taking the operator's placement out of that.
And of course, edge detection, there's always value in that because that also decreases variability, as well. Yeah, okay. Oh, Rob Bellinger, again, STM7 from Olympus, right?
Great, yes.
Okay, thanks for joining us today.
Yeah.
Right, man.
Yeah, have a good afternoon.
Well, there you go, the STM7 inspection and measurement series from Olympus, system from Olympus, I should say. Rob Bellinger joining us there. Dirk, thank you for doing a fine job as always with Tech Corner. And Rob, of course, thank you for coming down and doing that demo for us again.
And we didn't even break it when we were bringing it into the studio.
We almost broke our door, but got it in and we'll get it back out. Great, good stuff. All right.